Hey everybody, welcome to the Unit 2 CSA Study Guide 2021 to 22. We finished Unit 2. So these are the problems that will be on your CSA. When you have parallel lines, like you see here, and then this is L1, L2, this is your transversal line. These parallel lines create special relationships. They're either going to be congruent relationships or supplementary relationships. We can see we have an obtuse angle right here and another obtuse angle. So it wouldn't make any sense that these could add up to 180. So by deductive reasoning, we know that they have to be congruent angles. Angle A is congruent to angle B. If that's the case, their angle measures are the same, so we can just set them equal to each other. 15x plus 45 equals 26x minus 10. And now we have a three-step problem. We have variable terms on both sides. Pick one to get rid of. I'll get rid of 15x because I want my coefficient to be positive. Slash out the 0. Bring down everything that you don't interfere with. 45 equals 26x minus 15x is 11x minus 10. So you just bring the whole, make sure you're bringing the entire term down. You don't leave behind the sign. And now we're adding 10 to both sides. We have a two-step problem. Get rid of the constant first. 45 plus 10 is 55 equals 11x. And it's an integer coefficient. We can divide by 11. X equals 5. And then it says, substitute the value of x into the equation to find each angle measure. Okay, I can do that. So this angle is going to be 15 times 5 plus 45. 15 times 5, I believe, is 75. 75 plus 45 adds up to 120 degrees. And I know that they're congruent, so I know that this angle equals 120 degrees also. This will later be a video, so you can pause it if you missed anything. All right, there's our big, complicated, multi-step equation here for question 2. We know that we need to apply the distributive property first, so we're gonna distribute. That will help me know that question 7, how do you solve linear equations? You solve linear equations by applying the distributive property. Combining like terms and inverse operations. So just those are the three properties that we're using to solve these linear equations in one variable. You also apply these when you're solving and rearranging in our next unit, Unit 3, when we're going to need to solve it for y to put it in slope-intercept form. We'll still be doing that. I'll try to push that up so I can start question 2. So we did the distributive property.
Are these going to be like the same on the test?
The same the same steps, but the numbers will be different. Yeah. Negative 3, negative 1/3 times positive 6x is minus 2x. Negative 1/3 times negative 36 is plus 12. So we did the distributive property. We're going to look to see if we can combine any like terms here on this next step, which we can. We have two constants on the left-hand side. We're going to just combine them. And we always write in descending order, so the negative 2x will be written first. And now we can combine the negative 3 plus 12, which is plus 9. Okay, and finally we're on to, there's no more like terms to combine, so finally we go to inverse operations. Pick a variable term to get rid of. Let's add 2x. 9 equals 6x minus 6, add 6. Six x equals 15. But I make a mistake here. And then when we divide both sides by 6, I ran out of space. I get 15 over 6 equals x. And I could do some simplifying. 3 goes into that 2 times, into that 5. 5 halves. If you have your doubts, you can put it back in there and try to do a check. Let's see what that would look like. Negative 3 minus 1/3 times 6 times 5 halves minus 36 equals 4 times 5 halves minus 6. Negative 3 minus 1/3, so that's 15 minus 36 equals 10 minus 6. Negative 3 minus 1/3. This is negative 21. Negative 3 plus 7 equals 4. Hey, it did check. Woo! Pretty complicated check. Okay. On question 3, we end up with a question talking about the perimeter. So we need to explore what the perimeter is. We have the length and the width given. So perimeter is when you walk the outside of an object. In this case, it's a rectangle. So it's going to be length, width, and width. So the perimeter is equal to length plus width plus length plus width. We can simplify that since we have two L's. We just write it as 2L plus 2W. We're given that the perimeter is 64. And then we're given that the width is related to, is equal to 4 inches less than half the length. So W equals 4 inches less. I'm going to be subtracting 4 and 1/2 L. Once you have this value of W, you're going to substitute it in for the W up here. So we end up with 64 equals 2L plus 2 times 1/2 L minus 4. We replace the relationship in for W. 64 equals 2L. We got to distribute now. 2 times a half L is plus L, and then minus 8. Be really careful to make sure you multiply the 2 times the negative 4. 64 equals 3L minus 8. I got to go down here. I ran out of space. I'll rewrite it again. 64 equals 3L minus 8. This little object here is from Illuminate, so there'll be a box there to enter your values. We need to add 8 to both sides. 72 equals 3L. Divide by 3. So I don't run out of space. And that's 24, I believe. So L is 24, and so W equals 1/2 times 24 minus 4. 12 minus 4, the width is 8. Then we can check it. We can put it in there, 24 here and 8. If I double check, if I take half of 24, it's 12 minus 4 is 8. So that checks out. And then I need to just add it up. 24, 24, 8, and 8. That's 24, carry the 2, 64, and yes. Question 4. Okay, so this gets us to that situation where we are looking at it, we're saying whether it's no solution, one solution, or infinitely many solutions. So if you look at the second essential question, in this case it's question 8. This is essential question 2 for unit 2. How could you tell without having to actually solve these whether there's infinite solutions or no solutions or one solution? Okay, so we're looking to see if there's 3 cases, right? Case 1, the coefficients are different. Oops, I gotta zoom out. The coefficients are different. So the only one, this has a coefficient of 1 and 1. This has 4. I need to distribute this negative 2, and I get 4y plus 4. So the coefficients are the same. The coefficients are the same, but here the coefficients are different. That means there's one solution. Case 2. The coefficients are the same. But the constants are different. If that's the situation in case 2, there's no solution. So we go up here and look. Coefficients are the same. Constants are the same. That doesn't fit. Coefficients are the same. Constants are different. This is the no solution. And on the test, it's not necessarily you're going to have one of each. There might be 2 of the answers might be one solution, or all 3 of them. So then we're left with case 3, where both coefficients and constants are the same. There's a symbol for that, infinite solutions. And that's what we have here. Infinite number of solutions. Problem question 5 is the easiest problem on the test. They want you to put in a value that's going to make this an infinite solution problem. So we have to simplify a little bit. Yeah? No, it's closed book test. Good question. Combining negative 4c plus 12c, you get 8c minus 3. Oh, I made a mistake already. I didn't distribute. It's minus 6. Now it's fitting. We have the minus 6. To make infinite solutions, we just need positive 8c. Question 6. Okay, so we have some geometry from Unit 1 coming back over here. We have to apply that the exterior triangle.
Did we do 5?
Yeah, that was 5. That was question 5. Exterior triangle angle theorem. That states that the exterior angle, triangle angle, equals the sum of sum of the two remote interior angles. So all we have to do is recognize they're all 3 different angles, but this angle plus this angle will add up to this outside angle. So we can do 8x plus 12 plus 5x plus 20 adds up to 16x plus 8. Now we're just combining the like terms. 13x, 12 and 20 is 32. We have variable terms on both sides. Let's subtract 13x. 32 equals 3x plus 8. I'm out of space.
Can you leave that up for a bit?
Sure. I'm going to subtract 8 from both sides. I get 3x equals 24. So x equals 8. And now I need to find the angles. 8 times 8 is 64 plus 12. $76 degrees. 5 times 8 is 40 plus 20 is 60. 16 times 8 plus 8 is 136. And then a quick check. 76 plus 60 does equal 136, so this is the correct answer. So we know the answer to question 7, and the answer to question 8. What are the possible solutions to a linear equation? How can you determine the number of solutions? Is the answer I just put up with the different case scenarios. Is that okay if I push this up? This is your answer here. The 3 different cases. And with that, that's the entire review.
Can you leave that up?
Sure.